So our next speaker is from the Indonesian Institute of Sciences. From my understanding, Dr. Skuma cannot make it today, so he sent his co-author to present the paper on biomass utilization in the creative industry in Indonesia.
Hello, good afternoon.
Mohana, maybe you need to unshare first, so the next speaker, Skuma, can share her slide.
All right, thank you so much. Give me a moment, please, to share my screen.
Yes, please.
Can everyone able to see?
Yes, yes.
All right.
Yes, go ahead.
All right. Good afternoon, everyone. My name is Almira. And Dr. Sukma sends his regards and apologies for not being able to present today. Therefore, I will be presenting the research on behalf of Dr. Sukma, and my name is Almira Fikrani. And I will be talking on the subject of biomass utilization in the creative industry of Indonesia. So Dr. Sukma is a research scientist for the biomaterial team at Indonesian Institute of Sciences, and his doctorate project involves the use of agricultural waste as raw material in the manufacturing of composite products. And his current research is the study of agriculture waste, such as banana stem front, areca palm leaf sheath, and as a sustainable resources to provide for biodegradable composite packaging. Whereas a little bit about myself, I have actually worked with Dr. Sukma for about a year on the research project of utilizing agriculture waste as biodegradable composite products. I graduated with a product design degree from LaSalle College of the Arts, Singapore, and continued my design master's in Bandung, Indonesia, where I focused on exploring and upcycling post-production waste material for circular and regenerative futures. Right now, I am a co-founder of a startup called Topa and a cultural research lab Foodless Initiative in tackling excessive post-consumer waste issues by utilizing agricultural waste materials and implementing a decentralized micro-manufacturing approach to alleviate environmental burden and strengthen socioeconomic resilience in communities around Indonesia. For our presentation today, we will be covering the subject of biomass waste in Indonesia and its utilization through several case studies. So Indonesia itself, it's a mega biodiversity country where you can find unique 539 fauna, 629 flora, and 55 microorganisms across the archipelagic island. We believe that our abundant biological resources could be an asset when we are facing the current global climate change crisis. And if applied well, it could really push us to the forefront of sustainable development. One of our abundant resources can actually be found in biomass waste, solid biomass waste from forestry, agriculture, and plantation from commodities such as rice, corn, cassava, coconut, oil palm, sugarcane, sorghum, areca. And the amount of solid biomass waste potential in Indonesia, although quite hard to pinpoint the exact number, but with there are various independent data. However, Dani and Wibawa 2018 estimates that there are 146.7 million tons of biomass residue which are generated per year. And its main utilization and conventional utilization is still for animal feed and fuel. However, if we just take a small percentage of that biomass waste and use it to create biodegradable cups, plates, packaging to replace plastics, and even create roof shingles, because Indonesia is quoted to be the second largest contributor of waste into the sea, with an approximation of 7.8 million tons of waste thrown away each year. And also now with the pandemic, it has shifted and increased the culture from offline buying to online purchasing to accommodate basic and subsidiary needs, which also then increase the number of packaging used and discarded. And therefore, these excessive packaging and push the waste issue to an even more critical point by ending up in landfills or rivers and makes their way into the sea. We believe that biomass waste research and development for the creative economy can be the solution to the abundance of post-consumer waste by replacing non-perishable materials into biodegradable products. And in 2019, the Indonesian government finally issued a new creative economy law, which encompasses 7 purposes. This is to encourage all aspects of creative economy by development of culture, technology, creativity, innovation in the Indonesian society, and hopefully it will create change in the global economic environment. One of the key points are to improve the welfare of the Indonesian people, increase the state's revenue, to create a creative economy ecosystem which is globally competitive, create new job opportunities, and that favors the artistic and cultural values of the people and the local economic resources. And to mainstream the creative economy in the National Development Plan. This new law can speed up development of the creative economy in the country, especially the way creative economy can contribute towards social impact, innovation, circular economy, and sustainable development. It is important that we shift towards regenerative systems for circular economy and sustainable development goals. There are many SDGs that we can align with. However, these 3 stands out the most in utilizing biomass waste utilization in decent work and economic growth, industry innovation and infrastructure, and responsible consumption and production. The systemic approach to economic development is designed to benefit businesses, society, and the environment. A circular economy is regenerative by design and aims to gradually decrease the consumption of finite resources by designing out waste and pollution, and keeping products and materials in use as much as possible so that in the end it will regenerate the natural systems. This is why biomass waste utilization could be the answer. Here are some case studies and experimentation on biomass waste utilization. The first one is banana stem fronds, which has been immersed in chitosan solution for 30 minutes to strengthen the cellulose, and it is then dried for 10 minutes before being heat pressed into shape at about 140 degrees to strengthen and create moisture and waterproof plates, such as pictured. Our research also tried the usage of sorghum biomass waste with combining it with molasses for roof shingles, and the process is very similar. The pulp mixture is 20% molasses and 80% particle sorghum. It is heat treated and then pressed into shape at 180 degrees. This is also waterproof as well. And the next case study is pelepah, one of the product that's already in the market. Pelepah is the first agricultural waste material that we use, or biomass waste material that we use, is made from areca palm leaf sheet. We added value to a material that are usually thrown and burnt away, thus reducing the amount of pollution to the atmosphere. The product itself is food safe, water resistant, oven and microwave safe. We are able to reuse it up to 30 times with gentle use and gentle wash. And we have also done a carbon footprint calculation on the production process with a sustainable consultant company. And because we are using areca palm leaf sheet waste, the pelepah product is carbon neutral and degrades also within 60 days in soil. If you use our products, you have already saved an estimated of 130 grams of CO2 emission per product in comparison to plastic packaging of similar volume and size. The possibilities of this material usage is endless, especially to replace single-use products that we have in the market right now. For our first pilot project, we started in South Sumatra and in Jambi, where there are a lot of areca palm plantation. And if we maximize the potential in just that one region, it could produce up to 45 million products a year. And currently, we work together with smallholder farmers and communities there for direct and visible impact. And before moving on, we would like to talk a little bit about our technology. So We actually create our own machines as well. With our innovative system, it can be adapted to scale and in accordance with the needs and capability of the area. And we have the ability to custom design the technology. And that's why we adopt this concept of decentralized manufacturing process, which is modular and compact. And these design systems simplify and speed up the maintenance process with parts that are already available locally and allows the community to assemble and easily maintain them themselves. This appropriated scaled machine is designed to allow the system to be more flexible, adaptive, and really in accordance with the capacity of the local community. So we can even place these machines that we make in remote areas. And this decentralized scheme is especially appropriate for the local market in each areas, and it also promotes local pride and strength. In developing our solutions in utilizing biomass waste, we take into consideration the local resources capacity from the material itself, the supply chain, as well as the human resources skills and the infrastructure in the area. A feasibility study and in-depth research beforehand is very much key. And another key component is actually the market research. So in order for the product to be successful, it needs to be accepted and used in the market. And the success of the biodegradable products in the mass market would then generate greater impact for the environment, and we will be on our way towards a circular economy. Our business model involves a multitude of stakeholders within its design for a holistic and sustainable business. In the downstream, we partner with local village enterprise and work together with the local government. On the upstream, we partner with environmentally and socially conscious businesses and organizations to campaign and market their products. Throughout the development process, we work with established organizations, CSOs, for community development, and with institutes such as an Indonesian Institute of Science. We also work together with Paragon Technology and Innovation for biomaterial research and product development. Creativity can be observed as a complex process of innovation through mixing several dimensions such as technology, science, economy, and culture. But it should not be seen as a one-dimensional spectacle, but with respect to its multi-layered nature. Sometimes activities can have characteristics of one or several creativity layers. However, the most effective are those which are combining more of them and possibly all four. So this is what we are trying to do right now, really collaborate between multidisciplinaries from scientific fields, from technological fields, creatives, and ultimately, this is all for our regenerative futures and circular economy through the utilization of biomass waste in the creative industry of Indonesia. Thank you so much for your attention.
Okay, thank you very much for your talk. So do we have any questions from the audience? Okay, let me start with one question. From my understanding, like all those biodegradable material or like paper cup actually is not waterproof. So you need to have some plastic coating on the surface, right? So I was very impressed by the project you mentioned, Pleba. But how do you make it waterproof so the water will not soak the material?
So with Pelepah itself, the material is already, they have this layer of wax, natural layer of wax on top of it that already repels water. Not for a long time, maybe for room temperature water, it can repel it for like 2 hours, 3 hours, okay. A long time. Hot water, very hot boiling water, it can hold its shape for about 30 minutes before it kind of softens, the material itself softens. And so that's why we didn't, for the Pelepah itself, we didn't do any extra treatment, pre-treatment to the material, unlike the banana teeth and the sorghum. Those we need to combine it with molasses and with chitosan to ensure that it is waterproof as well.
I see. But if there is some wax natural wax in the material, right? When you put it in hot water, will this wax dissolve in hot water?
Oh, no, it doesn't. We have also tested that in the material itself, it won't. It's actually food safe. It doesn't contain any waxes that like transfers whenever you eat your food in it and stuff like that. And so yeah.
Actually, this is very exciting because you know, I don't like to use a paper cup or paper utensil because I know there's a plastic coating on the surface. So it's not very environmental friendly. But since you mentioned this material has a natural wax, and so you will be water resistant for a short period of time. But I think that's probably good enough for most usage, right?
Yes, I mean you eat only for like 30 minutes, right?
30 minutes, yeah. You don't need longer than that, right? So that's okay. Yeah, and you also mentioned this micro manufacturing strategy where you produce this product at the place you can find this biomass, right? But as you can imagine, the major market will be mega city like Singapore, right? We consume a lot of this disposable utensils. Yeah, so how do you there's a supply, there's an unbalance of supply and demand, right? Yeah. So how do you solve this issue in this area which you produce a biomass? Probably don't use a lot of these utensils.
Yes. So that's why we wanted to. At first, we wanted to be close to where the biomass materials are wasted and are produced, because then we can directly know, we don't have to transport the material, which causes extra, because logistics is expensive and things like that. But the fact that we can downscale our manufacturing in remote areas, or actually it doesn't have to be in remote areas, but in any areas. So for example, we make one closer to the city to Jakarta as well. We will be using biomass materials that can be found in the area, such as mostly in Java Island. The waste material are from rice, and those are the material that we use to produce the products like packaging, cups, and things like that. In Sumatra, because the most available material that are close to us are the sheets. So that we create those for near the bigger cities such as Palembang, which also consumes them. For example, if we do want to expand and export to Malaysia, to Singapore, there are a lot of plantation in Riau and in Medan, which, as you can imagine, is much closer to Singapore and to KL. That's where the industry, that we can put our micro manufacturing industry there, and we can supply products to the nearest city. So that's why we believe that this decentralization and micro manufacturing is one of the key in to be able to utilize as much biomass as possible in all areas and supply them to the nearest city or to the nearest market.
Okay. Yeah. Thank you.
Thank you for the question.
Thank you. So do you have any questions from the audience? Anyone want to ask questions? Nyala, right? Your name, Nyala? Okay, if there's no questions, I think I will thank the speakers and we'll move on the next talk, which is also the last talk for this section. Thank you.
Thank you so much.